Hello, very good evening, all of you. Am I audible? If I am audible, please reply. Please reply, beta. I am audible. Please reply. Okay, very good. If I am audible, we have actually we are doing some job in the yesterday's part. Ki how to get the electric flux, how to get that electric flux part. Okay, so we have started this thing. So we are going to discuss about it. But again, I'm asking the same question. There are few viewers now joined. So I'm audible to everyone. If I'm audible, please reply in chat box. Okay. I think I'm audible. And now what we have discussed in the last class, I'm just taking you in this back part. And I told you one thing very simply, what is the meaning of this Gauss law? So Gauss law we have started, and Gauss law we have discussed the phi is equal to closed integral E dot ds is equal to Q enclosed by F naught. So very first thing I told you, in the left hand side we are seeing this is the flux part, and the extreme right hand side we have seen this is the Q enclosed by F naught. This is the one part, and the middle second term is there, that is equal to closed integral of E dot ds. ds is the area vector beta, and E is the electric field. So by using this second term, we can calculate the total flux. Using the second term, we can calculate the total flux associated with the body, closed body. So we have done already discussed this thing in a detail in the previous class. Okay. Now come to the second thing, the phi is equal to Q enclosed by F naught. That means it depends only how much charge is enclosed inside the body. How much charge is enclosed inside the body, that is our thing. Now we have discussed one thing. Suppose it's a closed body is there, in that how much charges are present. How much charge is present? So we have seen that the Q1 is present, minus Q2 is present, Q3 is present. So using that we have discussed what is the total flux, the Q1 plus minus of Q2 plus Q3 divided by epsilon naught. So we told you this basic part, and I told you this total flux is independent of the size and shape of the closed surface. So it does not depend on how much big size it is or how much what is the shape of the body. So we have discussed this basic question, this is one surface, two surface, three surface, four surface, and we are seeing the total flux is the same in all surfaces because Q enclosed is same. After that I discussed very simple, this is sphere, radius r or 2r. If charge is same, that means flux would be same. Similarly, I had discussed to you one thing, there is the flux 1 and flux 2. If it is placed at the center or it is placed near to the surface also, that it will also remain same, because we are just checking Q enclosed. Where it is placed, position does not matter. Charge position does not matter if it is completely enclosed. But if charge is placed on the surface, discrete charge is placed on the surface, we do not define, or we cannot define what is the flux associated with it. So that is the one thing we discussed in the last class. After that I told you, okay, suppose this is one sphere is there, charge is placed here. So if charge is Q here, so we can cut it into two half spheres, or we can say hemisphere. So flux associated with one hemisphere would be Q by 2 epsilon naught. Similarly, for this cylinder, this is a big cylinder. If you cut at the mid, you will find this is the, due to this small cylinder would be Q by 2 epsilon naught. Similarly, two cones were there, and using this cone also we have discussed that very basic part it is. I think it is clear to everyone. Okay, this is a very basic type of question comes to you, and we can discuss those questions. Clear, beta? Now, using this concept, now we are going to discuss few more things where the charges related to this flux question comes to you and how to solve them. We are going to discuss one by one in detail. Now, I am taking a very basic and very common problem. Just wait. Okay, now wait. So very first thing I am just discussing that the cube problem beta. When I am saying cube problem, what is the meaning of cube problem? Listen carefully. That the cube problem is there. What is the meaning of cube problem? That means if this is a cube is there, if one cube is placed there, and in the cube if charge is placed, so what is the total flux associated with it? That is the question. So if I am drawing here one cube, you can see this is the one cube is there beta. This is a cube. This is the one cube is there beta. You can draw like this. This is the cube. This is the cube. This is the cube. The one cube is there. Okay. This is the one cube is there. We can check it. And in this cube, if I assume it, the side length is equal to L. How much side length? L. This is side length is equal to L. I am putting it. The side length is equal to L. And at the center of this cube, if I am placing here charge Q, at the center of this cube, I am just talking about putting a one charge Q at the center. So at the center of cube, just I am discussing. Hello Sai, Satvik, very good evening beta. Okay, I am audible. If I am audible, you can reply. Sai, Satvik. So this is a charge is placed at the center of the cube. If charge is placed at the center of cube, the very first question comes to us. Tell us what is the flux associated with the cube? What is the flux associated with the cube? So what is flux? So you will say directly, sir, this charge is enclosed completely inside the cube. Yes. So for completely enclosed, that means you can say, sir, Q enclosed divide by F naught. This is the formula. So using this formula, I can write the flux related to the cube is equal to Q by F naught. Q by F naught. That I can write it. That's the very basic thing. It's the Q by F naught that we are writing it at the center of Q. Now very basic question comes to us. Sir, there are how many faces in a cube? How many surfaces are there in the cube? If you see it, how many surfaces? So there are 6 surfaces. How many surfaces beta? 6 surfaces. At the center of cube, if you see it, what a charge is placed? That is the cube. Rahul Verma, sir, Gauss light LT highest how much, sir? Actually, this is not right platform to tell, and I think you have to wait for a few days. We will discuss and we will disclose our result. Okay, in YouTube also we will disclose, and offline also we will disclose, and maybe in a newspaper, and you will find in a advertisement also. So but right now, to give that score, that is the part of privacy of the institution, so I cannot tell, sorry. Okay, Rahul. Now come to this point. This is given to you. This is phi of q. So phi of q is equal to q by f naught. We can put it. So phi q is equal to q by f naught. That I am writing it is related to this. But in a cube, how many surfaces are there? How many surfaces? So you can say there are 6 surfaces. How many surfaces? 6. I will tell you. Just focus on the board. If you see here, beta, this is the surface 1. This is surface. This is the above surface. One surface. This is similarly one bottom. There the 2 surfaces are there. So 1 and 2, top and bottom. Similarly, this front and back, these are 2. Okay, the front side and this back side. And this is the 4th side and this is the back opposite side. That is also 2 surfaces. Total becomes 6 surfaces. And because this charge is placed at equal distance from all the surfaces, at equal distance, because it is at the center. So if you take the side length is equal to L, if charge is placed in this room, suppose I am assuming this room is the one cube, wherever you are sitting, whichever room you are sitting, just imagine that is the one cube. Just imagine that is a cube. And suppose at the center of this room, wherever you are sitting, just take as a charge q placed there. If you take side length is L of q, this is side length L, it is also L, this height is also L, this width also L. So this length is L, width is L, and height is L. All are equal. At the center, suppose charge here is placed, that is a q charge is placed, beta. So if you take the charge distance from this to this surface, this face, that is equal to L by 2. Similarly, this wall also L by 2. This wall also L by 2 from center. This floor is also L by 2. This ceiling also L by 2. And the front wall also L by 2. So all 6 faces are at equal distance. That means the flux associated with the each wall or each surface also equal. So I can say very simple, sir, this phi of q you want to write it. Phi of q, that is equal to 6 times of phi due to one phase. So due to one phase, whatever the flux is passing, just multiply with 6, that is equal to phi total, or phi q. And that is equal to, already we are seeing, that is equal to q by epsilon naught. So using this term, we can tell you directly the phi of one phase is equal to q by 6 epsilon naught. So phi due to one phase is equal to q by 6 epsilon naught. This is the flux associated with the this one phase, or flux associated with the total q is equal to q by epsilon naught. It is clear to you? Is it clear, beta? Sai, Rahul, and other persons also? You can reply. Whoever in the class, please reply it. Please reply, beta. Okay. Now I am assuming this is clear to you. Now come to the next point. What I am telling you, suppose this is a beta q is there. If it is a q is there, now second, in the second problem is that ki charge is placed at the, okay, Gayatri, very good beta. Now this is clear. I am talking about if charge is placed at the face center. If charge is placed at the face center, then we are talking about, just wait, I am just writing here the face center of a cube. You can say the face center of cube, beta. It's the face center of cube we are putting it. So face center of cube I am putting. Now question comes to you, what is the flux we have to calculate? To try to understand it. Suppose this room is, again I am taking, or wherever you are sitting in your room. So just assume that is the cube. That assume is a one cube. Okay. At the one cube I am assuming, suppose this room, studio room is also one, I am assuming it is a cube is there. And all sides are equal, that is equal to L. So this length is L, and this width is also L, and this height is also L. So I am taking it all are equal. Suppose one charge is placed at the here. At this place this charge is placed. Suppose this is this wall is there, and in this wall, this is the center of this wall. So I am assuming this charge is here. So this is placed at the face center. What we call it? Face center, beta. What we call it? Face center. So at the charge is placed at the face center. Now question again, because it's the plates on a surface, so we have to close the surface. We have to close the surface. That means the similar room I will make in the backward side also. So this is one room, one more room is behind it. So total becomes the total big cuboid type of thing is formed. Now in this big cuboid thing, you can see that this charge is now enclosed. If you take this small cube, then this charge on the surface, I cannot tell directly. So for making the answer, to get the answer, we are making one more cube behind it. Okay? If you are understanding, good. If you are not understanding, I will tell you one more. Yesterday we have discussed this thing. Suppose that this hemisphere is there. I am placing a charge cube. If I ask you what is the flux, you don't know. But if you enclose similar, this is you are putting here. one hemisphere also below it, then you know the total flux is a q by epsilon naught, because there are two hemispheres. So from one hemisphere it would be q by 2 epsilon. Similarly, I explained for this cylinder also. If charge is placed at here surface, surface. So to get the answer, we are making one more cylinder below it like this. So if you see this diagram here, we already know the total flux is q by epsilon naught, but due to one part only q by 2 epsilon naught. Similarly, in this cone question also, so you can get it. So same thing I am applying, same concept I am applying. If this room is there, if charge is placed at the face center, so I have to make one more room to enclose it. So total the two rooms are there. So total flux is q by epsilon naught, but because both rooms are identical, so how much is flux associated with one room, one cube? How much? So that is the half. That means q by 2 epsilon naught. So if I ask you what is the flux associated with one cube is equal to q by 2 epsilon naught, just tell me everyone, it is clear or not clear? Is it clear or not clear? Guru Sai, Gayatri, Rahul, Sai, another person also, you can tell this is clear or not. Now, one more thing comes to you, one more thing comes to our mind, ki sir, this charge, just like you have said here, is the total flux is q by epsilon naught when charge is placed at the center. Then you are saying that due to one phase it is a q by 6 epsilon naught. Good. But now here this is a q from q by 2 epsilon naught, because now total 6 sides are there. So you can divide by 6. So from one phase it would be q by 12 epsilon naught. The answer is correct or incorrect? The answer is incorrect. So don't do that thing. Why? I will explain it. This charge is here. So from this charge, this wall, this side wall, it at a distance of L by 2. This side wall at the distance of L by 2. This side ceiling is the L by 2. This floor is also L by 2. So these four faces are at an equal distance. But the front wall at a distance of L. That means that is not at identical distance. So that means flux associated with all these 5 walls are not same. These 4 walls same, this is different. Understanding? But this wall is there. So if I ask you what is the flux associated with it, definitely no flux is associated with this wall. So wherever the charge on whatever surface you are placing the charge, the flux associated with that surface is equal to 0. So I am saying the flux with the charge touching face, you can tell touching face, that is 0. That is 0. Because the flux, the field lines would be parallel to the wall. So that is not, so no flux is going to pass it. So this is a very simple thing. You can say the flux touching, that we can say 0, but other 5 we cannot tell it. We don't know the answer right now. Forget about it. How much would be the answer, that they are not going to ask you. Now third problem comes to you, that we call it the edge center. Edge center, beta. Edge center of cube. If I place the charge at the edge center means if I am assuming this wall, this is a room's edge, and here I am placing one charge here. This charge I am placing here. So if I am placing one charge here, and you can check if I am placing here that charge, suppose this is charge is equal to q. If I assuming this charge is equal to q, don't confuse with it, I am making like this. So if charge is equal to q, I am placing here. So now very first question comes to you, when you are placing charge q, this now the charge at the surface, that means you have to enclose first, then only you can tell the answer. So how to enclose? Try to understand. If you want to enclose with this surface, so you have to make one more what beta? Cube behind it. So this is one cube, one is behind it. So what is happening? Because this is one sphere, if I take it one sphere, right now I am not having a one sphere thing anything, but I'm taking it. Suppose I'm assuming this is a sphere. If you are having any ball or something in your house, you can check it, you can find it. Suppose I'm assuming this is a one sphere. By the way, it is not a sphere, everyone know this thing. If I assume this is sphere, if you are placing on the surface, so try to understand, it is on the surface, that means half part this side and half part behind it. So you have to make one room this side and one room this side, no problem. But actually this is not at the surface, it is at the edge. That means here the edge. So one surface is going like this and one surface is going like this. That means this portion only coming inside one, this portion is coming only inside one cube. That means this is how much? 1/4 part of this cube. Charge. This is 1/4 part of this charge cube. That means in one cube only 1/4 part is inside it. So what you can say is that the flux associated with one cube is equal to q by 4 epsilon naught. It is a q by 4 epsilon naught. This is the flux associated with. What is the flux? You can say directly the phi q is equal to q by 4 epsilon naught. Clear, beta? It is clear to everyone? Now see one more thing. When you are putting this charge at the edge, so this ceiling part and this front wall, that means this wall and this ceiling, that both things, they are touching this charge. That means charge is touching these two surfaces. So what is the flux associated with these two walls or two faces? That is equal to 0. So flux associated with the charge touching face, that is equal to 0. The flux associated with the charge touching face is equal to 0. That I am talking about it. So you can choose it. That is very simple. Now again the students can ask one question here. Sir, okay, you are saying the two surfaces are there, that is gone. Okay, still the 4 is remaining. So what is the flux associated with the one face? So can I divide by 4? Okay, this is a q by 4 epsilon naught, divide by 4, that means this become q by 16 epsilon naught. So this would be correct. The answer is no. It is not correct, beta. Why not correct? Please understand it. Suppose this charge is here at the edge, you can say. So this wall at a distance of L by 2. This wall also L by 2. But this bottom, if you see this floor at a distance of L. And the front wall also at a distance of L. So these two walls are different distances, L and L, and these two walls are at a distance of L by 2. Definitely all flux are not equal, not identical. So you cannot say q by 16 epsilon, that is also incorrect. Or if I ask you what is the value, we can't find right now. Understanding or not? This much we have studied now. So this is a case 3 we have discussed, that the edge center of the cube. It is clear to everyone? It is clear, beta? Now we are going for the next problem. That is a very simple thing I am putting here. At the corner of cube. At corner of cube, if I am talking about. If you are taking one corner and at corner you are placing it. Suppose this is the one corner is here. I am taking, suppose this is the one corner of this room. So I am placing, suppose this one charge is here at this corner. If I am placing one charge here at a corner, so now very first question comes to us is, sir, what is the total flux? So you will see when you are placing at the corner, suppose this is the one charge is there, sphere, I am assuming it. At the corner, that means how many faces are there touching it? Front, this the ceiling is touching, this wall also touching, and this front wall is also touching. That means 3 faces. One face means this is the ceiling, this is the what, beta? Side wall, and this is what? Front wall. That means only this much portion, small portion, this much portion. So now you have to make one more portion this side, one more cube you have to make it. So this become how much? Up to here, this distance. Similarly, we have to put above part also. So these are 2 rooms. These are also 2 rooms. Similarly, you have to put behind also. Total 2 room behind below and 2 room above. Total become 4 behind and 4 fronts. So total become how much? 8 rooms are there. That means 8 cubes are there. Then the big cube, the how much charge? Q by epsilon, or we can say the charge associated with the one cube is equal to q by 8 epsilon 8 q by 8, because 1 by 8 part of the charge only inside this room. That means how much flux associated with the cube. So you can say the flux associated with the cube is equal to beta q by 8 epsilon. Now very basic thing we can put it. Now second question comes to us, what is the flux? What is the flux associated with the charge touching face? So charge touching face that is equal to 0. That is a very basic thing we can say. But how many faces the charge is touching? This wall is touching, this front wall, this side wall is also touching, and this ceiling also touching. So 3 walls are there, that is gone. How many walls are remaining? 3, because total are 6. So front wall is remaining, this side wall is remaining, and this bottom is remaining. That means this floor is remaining. So 3 is remaining. So if you take this charge, from this charge, what is the floor distance? L. What is the front wall distance? L. This side distance also L. So total become, all are at identical distance. I am repeating again. It is also L. It is also L front, and this side wall also L. So all 3 are at equal distances. That means the flux associated with the all 3 would be also equal, because only 3 faces remaining. So whatever the total flux is there, it is divided into the 3 part, equal 3 part. That means this becomes q by 24 epsilon due to one phase. So we can say the flux associated with one phase, okay, so that is equal to what beta? Q by 24 epsilon. Don't confuse, these phases are where charge not touching. These phases are where charge not touching. Okay, so this is a very simple question that I am giving you. Now question is there, okay, are you understanding this part? If it is you are understanding, you can reply. Beta, please reply if you are understanding or not, because I am not getting your responses. So it becomes little difficult sometimes. Please reply, beta. Okay. No issue. I am just giving you some more things. That the Gayatri beta, very good. You are replying it. That's clear to you. Very good. So when we are talking about what is the flux associated with the each phase, we are talking. Now this same question sometimes comes in a different manner. I am talking about very simple. The same question sometimes comes in a different manner. So you have to be very clear about it, how to solve it, how not to solve it. That's the very basic question. Please focus on the board. I'm taking to you. Suppose there the one square sheet, beta. It's the square sheet A, B, C, D. Assume it is a square. If it is not looking like a square, but assume it. These side lengths are L. Okay, square sheet. I am writing properly. This is square sheet. No confusion should be there. It is a square sheet. And from center, this is the O point. This is the one point is there. This one charge is placed. This charge is placed Q at a height of L by 2. And what I am talking about, listen carefully. Suppose there is one, just give me 1 second. I'll take, suppose this one, suppose I am taking this one square. You can see this is the square, this is the L, this is the L, this is L. Okay, these are all sides are equal. This is the L, and from the center at a height of L by 2 one charge is placed. I'm saying again, from a center of this square at a distance of L by 2 one charge is placed here. You can draw like this picture if you are understanding. If you are not understanding the same question, I can place like this also. This is a charge Q at a distance of L by 2. At a distance of L by 2, there the one square seat is placed like this. L. It is A, B, C, D. This both questions are same beta. This question and this question, question 1 and question 2, both are same. If you are understanding the one, that is the same answer for the second. Very good evening, beta. Srinu. Okay, this is a question. Very simple question I have given to you. This is the L and distance is L by 2 of charge perpendicular to the surface. Now question is that what is the flux associated with the ABCD? What is the flux associated with the ABCD plane? Can we solve? Okay, I'm just giving you idea, you will understand it. Very basic thing that you have to focus. So what we are discussing in the previous slide, in this part, the very first case, if charge is placed at the center of Q, so what is the flux, total flux is there? Q by epsilon. Due to one phase is how much? Q by 6 epsilon we have discussed. Q by 6 epsilon. Darshini beta, hello. Okay. Now please check this part. We are discussing beta Gauss law. Okay, my name is Hari Mohan Singh. I think everyone is having this idea. Okay, if you are not having idea, I am just telling my name is Hari Mohan Singh and taking care of physics. Taking care of physics. Okay, and right now we are taking one topic, that is the electrodynamics. In that I am taking the very first topic, that is the we call in a starting part, that means electric charges and electric field, and that electric charges and electric field, in that the very simple thing we are discussing today, that is the Gauss law. Applications of Gauss law we are going to discuss. First flux calculation we are doing. So this is the part. This is the one cube. At the center of this cube the charge Q is placed. Okay, so we have discussed what is the total flux, that is the Q by epsilon, due to one phase Q by 6 epsilon. So when I was discussing this part 6, so I am repeating again what was there. Suppose you are sitting in one room, and in that room assume it that the cube, and at the center of this cube charge Q is placed. At the center of this cube charge Q is placed. Now if you see any phase, there are 6 phases are there, any phase you take it, the all phases are at equal distance. I will explain. Charge is here, from this wall is at distance of L by 2. This wall also at a distance of L by 2. The front wall also at a distance of L by 2. This back wall also at a distance of L by 2. This ceiling also L by 2. This floor also L by 2. That means this charge is at perpendicular to this any phase and at a distance of L by 2, and the flux associated with each phase would be same, and that is equal to Q by 6 epsilon that we have seen. So now the same concept we can apply in this question also. Now if you see this question, this is the one square seat, A, B, C, D, this is square seat, that length is L, okay, side length is L, and if you take from perpendicular to this phase at a distance of L by 2, charge Q is placed. So now question is that what is the flux associated with this part? So this is nothing, one part of Q only, one phase of Q, that means flux associated with the ABCD is equal to Q by 6 epsilon. This is the Q by 6 epsilon. Similarly here also this is the one cube is there, and again at a distance of L by 2 perpendicular from the center, so again the flux would be Q by 6 epsilon. Please reply everyone, this is clear to you or not? Gayatri, very correct answer beta. Other person also please reply. It is clear to everyone? It is clear beta? Very good. Now, if it is clear, now we are taking another problem. We are taking another problem, you will understand it. Very good, beta. That's it. Very good. Now listen carefully. I am asking one more problem. Problem number 3. If I say there is one square again seat, square seat is there. Assuming it is square. This is the L. Okay, square seat. I am writing properly. No confusion. It's the square seat, beta. In square seat, this name is A, B, C, D. And perpendicular to this plane, that's why I am putting dotted line. Try to understand. Perpendicular to this plane, there is one charge Q is placed at a distance of L. One charge is placed at a Q distance, at a distance of L, that is a place to you. Now, very first question comes to you, what is the flux associated with this ABCD? What is the flux associated with this ABCD? That is the question. We have to solve. This same question is asked in different manner also. I'll explain you, just to understand. I'll tell you. Suppose this is the one coordinate system. And I'm putting it, this is the coordinate system, X, Y, and Z. It's the X, Y, Z. And in this X, Y, Z coordinate system, if you are taking it, and if I place here, there's the one square seat is there. It is A, B, C, D. Side length are L. And here one charge is placed at L, 0, 0. By the way, if you want to write the coordinates, I can write here also 0, 0, 0 beta. It is 0, L, 0. It is 0, 0, L. And this point is nothing else 0, L, L. So this is a coordinate system I have written to you. Now try to understand. Neelam beta. Okay, please focus on the question and try to solve it. Okay, this is a very simple A, B, C, D. So I have written the coordinates also, I have written the charge also. This question and the fourth question, third and fourth, are same question. If you understand it third or fourth, you will get the same answer for the both. So can we solve this question? Try it. I am giving you again 40-second time. Try it. If you are getting, then it's a good idea. Then it would be good that you are understanding, you are getting some answer. Try to solve it now. Neelam, Gayatri, Darshini, Srinu, another person. Try and solve this part better. Okay. Now listen and check carefully. This question we want to solve. Again, I am taking to you the back slide. Just try to understand. Last case. This is when we are putting it. Very good, beta. Gayatri, correct answer. You are getting correct answer, beta. This is the I am talking about at the corner of the cube. When charge is placed at the corner, I told you this the corner is there, and here the charge is placed. So what is happening? If this corner is the place, that means what is the flux associated with the cube? That is equal to Q by 8 epsilon. Okay, Q by 8 epsilon. But due to one phase, that is the Q by 24 epsilon. because if you take any side, this is side, suppose this wall is there, and this wall at a distance of L from here, and this is also L, this is a square seat is there, and this is square seat at a distance of L from this charge Q. Similarly, you can take the front wall also, that is also a distance of how much? L. That is the again cube is there, oh sorry, square seat is there, L, and this is also L. This is a square seat at a distance of L, one charge is placed here at the quarter. So whenever any seat is there, if you are taking this seat, now you will understand, this seat is there, square seat, A, B, C, D, this is square seat is. From this perpendicular to this plane, one charge is placed at the above at one vertices, that is equal to Q charge. So what is the flux here? The same flux you will get here also. This is the one square seat, that is the side length LL, and from above means away from perpendicular distance from one vertices at a distance same L, one charge is placed Q. So what is the flux? If you ask, in both cases that would be the same, that the flux associated with the ABCD, that is equal to Q by 24 epsilon naught. Just tell me it is clear to everyone? Yes sir, no sir? Beta, it is clear to everyone? Okay sir, ma'am. It is clear? Gayatri, Neelam, Darshini. It is clear to everyone, beta? So this is the way to solve this question. We can solve it, we can get the answer. That's the very, very basic thing, we can put it. Got it? Very good, beta. Now I'll ask you one basic question. Try to understand it. Suppose one more question I'm giving you. Please focus, and if you're focusing it, definitely you are able to solve it. I'm giving you one very good question. Problem number 5. This is the one again square seat A, B, C, D. From its center, if I am for my understanding, I am drawing this part like this. Okay, this is drawing, and this distance is L. It is L. It is L. It is L. 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 This is center, beta. Okay, this is center of this square seat. It is a square seat. I am telling you, it is a square seat. No problem. No confusion should be there. And perpendicular distance from this center at a distance of L, one charge Q is placed perpendicular to this plane. Suppose this is the one plane is there. This side length is 2L. This is also 2L. Perpendicular from the center at a distance of L. Okay. So distance of L, this is a charge is placed here. So if I am asking it, you can tell me the answer. What is the flux associated with this all part? So if I ask you what are the flux associated with the ABCD, can you tell me what are the flux associated with the ABCD plane? Please tell me what are the flux associated with the ABCD. Sonali, beta. Guys, Dasini. What will be the answer, beta? Gayatri, Neelam. Gayatri, Q by 6 epsilon naught. Correct. This is same question that we have solved in the previous part. Question 1 and question 2. That is the same. So directly you will say that this is a Q by 6 epsilon naught. But if I say no, I am not interested in this part. I am not interested. Okay, because this is the side length is 2A, and this is a perpendicular distance, half distance at the cuboid. That means this is a 2A, then this is a A, that we can say. Now, or this is 2L and this is a L, we can put it, we will get the answer. Now come to the point. If I say no, I am not interested in this part. I am interested only this shaded region. Try to understand this shaded region. I am interested only in this shaded region. How much flux is associated? How much flux is associated with the shaded region? That's the question. Flux associated with the shaded region. That's the question. Flux associated with the shaded region. That's the question. If you, I'm giving you 1 minute time. That's a very good question. Very good question. If you are able to solve, that's a very good thing. So try to solve it. Try it, beta. Gayatri, another person, please try this question and tell me the what are the flux associated with this shaded region. Think carefully. If you can think, definitely you can tell the answer. Try it, beta. What is the flux associated with the this shaded region? Gayatri, you attempted good, but that is not a correct answer. Try again. Think carefully. What you have learned from the last two questions, if you understand last two questions, this is a actually related to these two questions only. If you understand the previous two questions, that means you can solve this question. Try it. What is the flux associated with this shaded region? Okay. Okay, I'm preparing for the next problem. That would be good. This it is a question, beta. Gayatri, that is not right answer, beta. I will tell you. Now please focus. This is a question if you are understanding. So if I take ABCD plane, directly you will say so this side length is 2L, this is 2L, this is 2L, that directly we can say. Okay, and 2L, 2L, 2L we are putting, and from the center at a distance of L, that means this is a Q center column. Directly you will say Q by 6 epsilon. But wait. This same question can be solved in another way also. These are 4 square seat beta. If you are taking this properly, you will say, sir, this is the 1 square seat. This is the 1 square seat. This is another square seat. So this is the 1 square seat is there. This is the 1 square seat is there. This is square seat is there. This is the square seat is there. There are 4 square seat is there. Due to 1 square seat, if you see, this side length is only L now. Side length is L and perpendicular to this corner, because this is the corner of this square seat of this. If I take the name also, I can put it. This is A, B, C, D, and this is E. If I'm saying this is F, this is G, this is H, and this point is O. If you are taking A, E, O, F, this seat, for this seat, how much is the flux? So you will say this is a corner question. That means Q by 24 epsilon. This is also Q by 24. This is also Q by 24. This is also Q by 24. Because for this plane also corner case. For this also corner case. For this also corner case. So directly you can say, sir, Q by 24, Q by 24, Q by 24, Q by 24. Multiplied by 4. Because there are 4 seats are there. Directly you will say Q by 6 epsilon. That we are getting on the answer. But now I am not asking it due to this complete ABCD plane. Now I am asking only 3. So you will say, sir, Q by 24, Q by 24, Q by 24 multiplied by 3, that you will get the answer. Now you are getting correct answer, beta. Gayatri, now your answer is correct. So you will say, sir, Q by 24 epsilon, but there are 3 parts there. That means this is a Q by 8 epsilon. That's the answer. That's the answer. Correct, beta. Gayatri, now you are getting the answer. Very correct. Now just tell me, everyone, it is clear to you or not clear? It is clear, beta? Clear or not clear? Gayatri, beta. Darshani. Another person, please reply. It is clear? This concept is clear to everyone? Okay. So now come to this next problem. That is what this is one cube is there. Again, side length I am taking a L. Side length is L, and there is one linear charge. There is one line charge is there, and on this line charge, charge density is given to you lambda. This is a linear charge density, beta. It is a linear charge density. Linear charge density. Try to understand it. It is the linear charge density. I am putting it, and that is the lambda. Now this is passing through the phase center. If you just see that is the phase centers are there, it is passing through. So now very first question comes to you. What is the flux associated with this cube? What is the flux associated with this cube? That is the question. Can we get the answer? Yes, definitely we can get. How much is this length is inside? How much is length inside? Can you tell me? What is the length inside? That is equal to, this length is also equal to L. This is L. What is the linear charge density? That is the lambda. Lambda into L, that becomes total charge. So what is the charge enclosed? So charge enclosed is equal to, beta, you will say lambda into L. Linear charge density multiplied by length. Directly you can say it. This is, you know, the total charge. Charge, you know, directly you can write the flux. So what is the flux? Flux due to the cube is equal to Q enclosed divided by epsilon. That means lambda, beta, you can write like this. It is a lambda L divided by epsilon. This is the flux associated with the cube. It is clear to you? Very good, beta. It is clear or not clear? Thank you. Thank you for your emojis. Thank you. This is clear? If it is clear, now come to this point, the next problem. Now there is a linear charge actually passing through the diagonal, body diagonal. When I'm talking about body diagonal. Body diagonal means from this corner to the opposite corner of this room. From this corner to opposite corner of this room. So what is this length? Can you find this length? This length is equal to how much, beta? Very simple thing. You can say very simple, beta. This length we want. This length we already know. If we understand this length, then we can put the Pythagoras, we can get the answer. Very simple. This length is equal to L. It is L, this is L, because this is a square sheet, that means this is L root 2. This is L root 2, this is L, that means I want to calculate this length. So how much length it would be? You will say directly, ki, sir, this length I want to calculate. So directly you will assuming suppose the distance is x. X is equal to under root of, because this is a Pythagoras theorem we are putting it. So this length would be how much, beta? L square plus L root 2 square is equal to x square. That means L square plus L root 2 whole square we can put it. L square plus 2L square total becomes 3L square. That means x is equal to root 3 times of L. That is equal to x. If you understand x, that means you can understand the charge enclosed. You understand the charge enclosed. What is charge enclosed? That is equal to lambda into x. Lambda into x, that means root 3 times of L into lambda. You can put it, you will get the charge enclosed. If you know the charge enclosed, that means you can find the phi. So what you will say, the flux associated with the Q is equal to Q enclosed divided by epsilon naught. That means root 3 times of L into lambda by epsilon naught. Are you able to understand, beta? It is clear to everyone? This concept is clear? Gayatri? Another question, please reply and tell me. It is clear, beta? This concept is clear? Very good, beta. Gayatri. It is clear to you. Other person also can reply. You can tell what is it is clear or not clear. Now another question I am giving you. Another question I am giving you. Try to solve it. Listen carefully. This is the one Gaussian surface. That means I am taking it as a sphere. Okay. And from this sphere, there is a one ring charge is there. Okay, this is a ring charge. It's the ring charge. Try to understand it. I'm writing it. You will understand this is suppose A point, this is B point. This is a ring charge, beta. Ring charge. Lambda, linear charge density lambda. Okay. And I'm telling you very clearly, it's a ring. Its radius also R and sphere radius also R. So you can see this A and B are nothing else. These are centers. A is the center of a sphere and B is the center of this ring. By the way, this ring is passing through the center of this sphere, and this ring center where the sphere is passing from B, and the ring is passing from A side. A means the center of this sphere. By the way, this sphere is nothing else Gaussian surface. That means what is meaning of Gaussian surface? Gaussian surface means this is the imaginary surface, spherical imaginary surface it is. So imaginary surface, that means this is sphere from that the ring can pass. Now very first question comes to you, what is the flux associated with the sphere? What is the flux associated with this sphere? That's the question. This is a question that is asked to you. What is the flux associated with this sphere that you have to calculate? And linear charge density given to you lambda of this ring. Now we have to solve it. Okay, so try to solve. You will get the answer. Okay, I'm giving you again 1 minute time. Very good question. Try to solve it. Try to solve it. Try to solve it. Tell me the how much flux passing through this sphere. Gayatri, Darshini, Neelam, Sonali, Ankit. Other person also, please reply what you are getting the answer. Try it. Okay. Now I'm going to solve it. If you are getting the answer, you can check your answer. It is a correct or incorrect. Okay. So please focus on the board. This distance, if I say here to here, this is R. Center to center. This distance is R. Okay. I'm taking this point, say suppose C, and this point is suppose D. I'm assuming it. Any problem? No. So if I join from A to C, it is also R, because this is the radius of this sphere. Similarly, from B to D, B to C also, that distance is R, because it's the very basic thing we can say. It is also radius of this ring. So try to understand. It is R, R, R. This is the equilateral triangle. Equilateral triangle means, what is the meaning of this? That means this angle is 60 degree. By the way, all angles are 60 degree. I am taking this as 60. Similarly, if you join A to D, it is also R. Similarly, B to D, that is also R. That means it is also equilateral triangle. That means this angle also 60 degree. So if you see this ring, how much angle of this ring is inside the sphere? So you will say 60 plus 60, that is actually 120 degree angle, means this part, this portion is inside the what? This sphere. So try to understand what I want to say. I want to say this is the ring is there and ring charge is there, beta. This is ring charge. Okay, this is a ring. It is a ring charge. Okay, and from center, if you check it, this portion, this much portion, that means 120 degree portion is inside this sphere. So 120 degree, that means directly you can say, so it's a length we have to calculate. This length, this is radius is R, this radius is R, no problem. So how to calculate? We already know one thing, that is equal to theta equal to arc length divide by what, beta? Radius. It's the very basic thing. But remember this theta we have to take in the radian, not in degree. So first thing you have to convert this 120 degree into the radian, you can get it. Yes. So you will say, sir, arc length is equal to, I want to calculate this arc length, this portion. So arc length is equal to theta into r. R means radius. So very simple thing, you will say, sir, 180 degree is equal to pi radian. So 1 degree is equal to how much? Pi by 180 radian. 180 radian. And 120 degree is equal to how much, beta? Pi by 180 degree multiplied by 120 degree radian. That means 0, 0 cancel. From 6, this is 2, this is 3. That means this is 2 by 3 pi radian. That is the angle first. You have to be clear about it. This much is the angle here. So if you are taking this portion you are taking. This portion, beta. This portion. So this portion angle is clear to you, 2 pi by 3. Now you can calculate the arc length. So you will say, sir, arc length is nothing else. Arc length is nothing else, theta into r. Theta is 2 pi by 3 into radius is r. This is arc length. That means this length now you know. If you know the length, just multiply by the linear charge density. What is linear charge density? Lambda. Just multiply. So you will say the Q enclosed is equal to lambda into arc length. Lambda into arc length. What is the arc length? You know the 2 pi by 3. So you will say lambda into 2 pi by 3 into r. That is the very basic thing. This is the Q enclosed. If you understand this Q enclosed, now nothing to solve. Directly you can say what is the flux through the sphere. So what is the flux through the sphere? So you will say directly the flux through sphere is equal to lambda into 2 pi by 3 into r divided by epsilon naught, means Q enclosed by epsilon naught. That means lambda into 2 pi by 3 into r divided by epsilon naught. Or you want to write little better way, that means this become 2 pi by 3, 2 pi into r into lambda divided by 3 epsilon naught. That is equal to 5 due to sphere. You can write it. It's the one question I have given to you, that the 2 pi r into lambda divided by 3 epsilon naught. Very good, beta. Gayatri, your answer is correct now. So this basic concept I have given to you, it is clear to you. Now everyone please reply, it is clear or not clear? This concept is clear, how to solve the question? Clear, beta? Now I am taking to you some more problem. Already PYQ problem, try to focus it. Another basic problem is there. Suppose this is the one square sheet is there. Square sheet A, B, C, D. Square sheet. It's a square sheet, and in this square sheet, if you're checking, there the one electric field is there. Uniform electric field. It is a uniform electric field like this. It is a passing at the E up to a distance of L by 2, and this side length is L. Okay, parallel to this plane. Okay, now question is very simple. Find the flux associated with the ABCD. Find the flux associated with the ABCD. First question. Second problem, PYQ already. It is a NEET PYQ, beta. Next problem. This is the one square sheet. Again, I am taking it. It is the A, B, C, D. I am putting it. And now there is also electric field is there. What is the electric field, beta? This is the electric field. This is the electric field like this. Okay, this is the electric field. It is the electric field. It is the electric field, beta. It is the electric field. That is equal to E. It is the electric field. That is the electric field. I am putting that the electric field is E and angle theta with this side. And this is also square sheet. That means length is L again. Side length is L. Again, question is there. What is the flux associated with the ABCD? What is the flux associated with the ABCD? That is the second problem that we have to solve it. Okay, so will you try? Okay, will you try this question? And at the end today, I will give you one formula, very important formula. Okay, suppose there is one charge Q is there at a distance of I can say X, and this radius is equal to suppose R, and this is a ring we can say, or disk we can say, disk, or you can assume it ring. The flux passing through this, that is the question. That is the this angle is theta. So we have to find the flux passing through this disk, or you can say flux passing through this ring. Both terms is same, no problem about it. That's the very basic thing that we have to solve. Mohammed, Asik beta, it is clear. Now we have to solve this question. Question number 1 or 2 or 3. 3 I will give you direct formula. You have to understand it. Okay, then we will bind the class. Very first thing, just check. This is the one sheet is there. I'm taking, suppose this is a square sheet. It is a square sheet, and the field is parallel to this sheet up to this L by 2 distance. Parallel. But field is parallel to this sheet. That means how much flux is associated with this sheet? how much is flux associated with this seat? The answer is 0. So what is the flux associated with this? 0. How much? 0. Because for that the field should be perpendicular to this seat. Field should be perpendicular to this seat. Second problem I am taking it. Now again, if you take, this is the one square seat is there. Now field is like this. This field is going at some angle, but it is again parallel to this seat only. Again parallel to this seat. That means how much is passing through this perpendicularly like this? 0. So what is the flux associated with this A, B, C, D? Again answer is equal to 0. Again answer is equal to 0. It's a very basic thing that we have to solve it. This is the question that I am giving you, and I am just explaining this question, and then I will bind the class. Tomorrow we will see the applications, that means field due to the spherical cell, linear charge density, and seats is there. Okay, finite seat, infinitely large seat is there, maybe conducting or non-conducting. Their fields and their graphs we will understand. Okay, tomorrow's class. So that value is equal to nothing else. You have to understand it. How much this value? This is our question. So I want to write it. This is a very basic thing. This is disk is equal to beta q by 2 epsilon naught into 1 minus cos theta. 1 minus cos theta. Okay, its derivation I am skipping for now. This is q by 2 epsilon naught 1 minus cos theta. This theta is very simple. So you can say what are the cos theta beta? This is x. This would be under root of x square plus r square. You can put it. So you can put, and you can write this like this also. I am writing here this term. Try to understand it. This is the phi due to disk is equal to q by 2 epsilon naught beta. Q by 2 epsilon naught bracket 1 minus cos theta. Cos theta would be x upon this. You can say x upon under root of x square plus r square. Q by 2 epsilon naught bracket 1 minus x upon under root of x square plus r square. That is the very simple thing we are putting it. Understanding or not understanding beta? It's the 1 minus x upon under root of x square plus r square. This is the answer. Okay, that you have to remember it. Thank you so much for your time. Okay, the next class is chemistry. You can join that. Thank you beta. Bye bye.